Good morning, students. This is session 3 from Communication Network, Unit 1, Fundamentals and Data Link Layer. So here we are going to see an example problem. Consider a bus LAN network with the data to be transmitted is 9 Mbps of length 1 kilometer. The time to send a frame is 500 bits from one station to other. The propagation speed is given as 150. We have to find the total time taken to transfer the data packets. Assume the distance is 500 meters. The mean time to send a packet is equal to propagation time plus transmission time. The propagation time is taken as the propagation distance by the propagation speed, and the transmission time is taken as the frame size divided by the data rate. What is data rate? The time to transfer the data. So that is given by 500. 500 is the propagation distance that is given in the question. Given question. Divided by 150 milliseconds. 150 is the propagation speed plus the frame size is 500 bits divided by the data rate. Data rate is 9 megabits per second. It is taken as bits per second. So 9 into 10 to the power of 6. That is 9 followed by 6 zeros bits per second. When we solve this equation, we get 58.88 milliseconds. Then the signals transmit at the same time will interface at 250 plus 250 divided by 150. What is 250 plus 250? It is the total distance. From station A to station B is 250, and from station B to again to station A is 250. Totally 500 meters. That is the total distance both from A to B and B to A. Divided by the 150 is the propagation speed. Thus we get 3.33 milliseconds as the total time for the signal to transmit in the channel. Next one. And this is an internet. Internet is a combination of WAN and the LAN. It is a globally connected network. So each network is connected to the internet through an access point. And these access points are connected to the regional internet service providers, that is regional ISP. And all these regional ISPs are connected to the national ISP. And thus forming an internet connection with the combination of both WAN and the LAN. Next slide. Protocol layering. What is protocol? It is a set of rules. What is layering? The classification of the networks into several layers, layer 0, 1, 2, 3, 4, 5, 6, 7 as in OSI model, and the network should be designed effectively such that these layers perform several functions to transmit a particular data from one node to the other node. Next one. And this is the protocol layering. We have 5 layers from host A and same in the host B, and each layer there is an interface. What is an interface? Interface is an intermediate junction between the two layers, and these interface connects two different layers and helps in the transmission of data from one layer to the other layer. The physical medium is the medium or the cable through which the data are transferred, and each layer performs certain functions. The layer 1 performs the establishment of the channel, and layer 2 transmission of the frames, and layer 3 establishing a specific route and then routing of the information, and last presentation and application of the following data. And these are the functions of the layer as we have seen already in the OSI model. Next slide. Protocol. It is a set of rules that governs the data communication. Important elements of protocols are syntax, semantics and timing. Syntax means the format of data or a structure, how it is presented. Semantics is the meaning of each section of a bit. Timing means at what time the data are sent. Next we have the peer-to-peer. What is peer? Peer is a node or a computer, and if there is a connection between two peer, it is called peer-to-peer architecture. In the network architecture, a set of layers and the protocols all together form a network architecture. Between each pair of adjacent layer, there is an interface. It defines a primitive operation between these two layers. And the interface and services are classified as different layers as n plus 1, n and n minus 1. The following diagram will explain the interface and services between the layers. Here is a diagram of interface and service. Here the layer layer N has PDU, PCI, SDU and ICI. What is PDU? Protocol Data Unit. What is PCI? Protocol Control Information. And what is SDU? Service Data Unit. And what is ICI? Interface Control Information. Then the layer N plus 1 has IDU. IDU is the Interface Data Unit. And the layer N minus 1 have similar as layer N. Okay, these layers sends the data and it has some control information for sending these data, and protocol interface also governs the transfer of these data between the layers. Next slide. The communication between the two sides in the networks are performed through these layers with the help of SDU and PCI. That is sender data unit and the control information unit. And these units helps to transfer of the data along with the header. What is header? It is similar to the initial of a particular name of a person. These headers holds the information of what kind of data we are going to transmit in a network. Next one, SDU. It transfers the user data by layer to layer, and PCI to perform service function, and PDU the combination of SDU and PCI. ICI, it passes temporary parameters between N and N minus 1. IDU, the total unit of information transferred across the layer boundaries. Next one, the types of services are classified into two types: connection oriented service and connectionless service. The connection oriented, there is a fixed path from source to the destination. Best example is a telephone connection. Whereas connectionless, there is no defined path from source to the destination. The mode of transfer is in ideal condition, and the data that is transferred in the connectionless services are called datagrams. The connectionless service, we have the best example as UDP, that is user datagram protocol, and connection oriented services, the best example for the protocol is TCP, transmission control protocol. OSI model, these model have certain following services provided. They are that provides a peer-to-peer logical service with physical implementation. It provides the standards for communication between the system, defines a point of interconnection for the exchange of information between the system. Each layer should perform a well-defined function, narrows the options in order to increase the ability to communicate along the layer. This is the layered protocol of the OSI model, and each layer, as I have told you, from 1 to 7, physical layer, data link layer, network layer, transport layer, session layer and presentation layer. And these layers transfer the informations from bits, frames, packets, segments and as data. Next one, analog and digital signal. So analog signal is a signal that is transferred as a physical quantity. Digital signal is a signal that is transferred as zeros and ones. Here is a difference column to differentiate the analog and the digital signal. Analog signal is a continuous signal which represents physical measurements. It is denoted by a sine wave. Sine wave is a curved wave. Okay. Digital signals or discrete time signals generated by the digital modulations. It generates square waves. It is stored in the form of wave signal, and these digital signals are stored in the form of binary bits. That is nothing but zeros and ones. Subjected to the deterioration by the noise during transmission in the case of read and write cycle. Whereas digital signals are noise immune. They are not subject to the noise during the transfer of the digital data. Periodic and non-periodic signal. Here comes a tabular column to list the difference between periodic and non-periodic signal. A signal which repeats itself after a specific interval of time is called periodic signal. The signal which does not repeat itself after a specific interval of time is called aperiodic signal. The signal that repeats its pattern over a period is called periodic signal, and the signal that do not repeat are called aperiodic. They can be represented by the mathematical equation, whereas aperiodic signal cannot be represented. They are deterministic signal, whereas aperiodic signals are random signal and they are not deterministic. Service provided by the network layer. The network layers provide certain services, and they are unacknowledged connectionless service, acknowledged connectionless service, acknowledged connection oriented service. So connection oriented service is that it provides a fixed connection. The connectionless service don't have a physical connection. And acknowledgement is the reply generated by the receiver after receiving a particular frame of data. And unacknowledgement is the receiver does not send any authentication information that the data are received successfully. Framing. Framing is a very important concept in this fundamentals of data link layer, and framing in the data link layer separates a message from one source to the destination and from the other. To serve as a network layer, data link layer uses service provided by the physical layer. At the destination, checksum is used to recompute whether the data are successfully received. Checksums is used to send the data with error free. The breaking of bit streams by inserting spaces or time gaps is called framing. So each and every data are inserted by a frame or a time, that is breaking of the signal, in order to ensure that the data are successfully transmitted and successfully received at the receiver end. And there are several types of errors. So error is that the message gets modified. It becomes an error. One such is single bit error. Another one is burst error. The single bit error, a single bit gets changed while transmission. Whereas in the burst error, 2 or more bits or a block of data gets changed. And this results in the burst error. Following are the constraints: error detection, redundancy, reduction versus correction, retransmission, forward error correction, coding, modular arithmetic are the concepts to be handled in order to avoid error and support error-free transmission. Error detection. So error detection, in this the user data are transmitted as the data words, as K bits, and these data words are converted into the code words, so that the data becomes more secure in transmission, and these data are error free during the transmission in the physical medium. Once the receiver receives these code word as n bits, they are converted to the data word, that is decoded as K bits, and the original data is received successfully. Next one is error correction in block coding. In the block coding, the data are sent as a fixed blocks. In the block coding, the storage capacity is very low, but the data are successfully sent with error-free condition. The same constraint is used. The user data is converted into the data word, and it generates a code word to be transmitted to the receiver side through the physical medium, and the code words of n bits are decoded as the data word and is received by the receiver. This is the Hamming distance. What is a Hamming distance? When two different code words are used to represent and transmitted, the difference in the bits of these two code words is called the Hamming distance. It is given as the minimum Hamming distance d min, small d suffix min, d min, minimum Hamming distance, where n is equal to m plus r. M is the message and r is the check bit, n bit code word. It is given by the formula 2 to the power of h greater than or equal to m plus h plus 1. Next one is the cyclic redundancy check. The cyclic redundancy checks helps to provide the parity method that detects only odd parity errors. Here we have the generated message and the message. When we divide these two and gets a reminder, the reminder gets added to the original message, and once again if we divide with the generated message, we get the reminder as 0. If the reminder is 0, then the data are successfully sent. This helps to avoid odd parity bits in cyclic redundancy check. Thank you.